Finding the largest number in a list is one of those problems that's easy enough to do in everyday life that when we have to do it, we often don't realize how many shortcuts we take and assumptions that we make. In order to create code to teach a computer to accomplish the same task can therefore be kind of difficult. What we have to do is strip away the benefits we have as human beings over computers so that we can understand this problem from an algorithmic point of view. When looking at this list of numbers, most people will arrive at the maximum of 14 through some thought process that sounds like, well, we have 1-digit and 2-digit numbers. We know 2-digit numbers are bigger, so I only have to look at the big ones. Now, between negative 13, 14, and 12, we can ignore negatives because they have to be smaller, and 14 is bigger than 12. Okay, so we have some issues here. Noticing the 1-digit trend about how large most of the numbers are relies on seeing all the numbers at once, when the computer has to access them one by one. Also, the cutoff of 1 versus 2 digits is entirely arbitrary and a consequence of our base 10 counting system, which the computer doesn't even use. To the computer, all numbers look the same, and it can't come to conclusions about vague patterns like most are 1 digit long. So let's instead try to reframe this problem in order to eliminate these shortcuts, and also keeping in mind that our algorithm should apply to any amount of numbers of any particular size. So, hypothetically, you're locked in a room with nothing in it except for a desk with a towering pile of paper on it, and you're given a pencil and a blank sheet of paper. Each piece of paper has an integer printed on it. You'll be paid a large sum of money if you can successfully find the maximum value without changing the current seemingly random order to the paper. How would you attempt to solve this problem? Our old strategy of looking for patterns is no longer available since we have to flip the pages over one by one. So forget about planning ahead, let's just see what happens when we get started. You flip over the first page, and you see an enormous number, 10 digits long, 2,924,000,000. Alright, great. Maybe we got lucky, and this is the maximum number. Maybe all the rest of the numbers are, under 1,000. Okay, so you turn 2,900 whatever million over, and flip to the next page. Oh, this number looks really similar. We have to flip back to the first large number so that we can compare the two. Once we decide which one's bigger, we should probably write it down so we don't have to flip back in the future. Turns out it's the second number in this case. The next few numbers are small. You ignore them, of course, and continue flipping. Now we get to something that's bigger than the number we have written down, so we don't have to remember that old number anymore. We can write down this new maximum instead. You find yourself only writing down a new number when you find something greater than the one you have currently written down. Numbers under that get immediately ignored since you know they're not bigger, they're not the maximum. This is an algorithm that can be coded in a computer. We made no assumptions, took no shortcuts. It's just simple array accesses and mathematical comparisons. So what did we do exactly? We assumed that the first number was the max. We wrote it down. We checked the second number. If it was less than the number we have written down, we ignored it. If it was greater, we changed which one was written down. Then we checked the third number. If it was less, nothing. Greater, change. Check the fourth number, and so on and so forth. At the end of this process, the stored number will be the grand champion maximum that beat out all the other maxima. How do we code this? One thing to note real quick is that computers in code, and array indices in particular, typically start counting at 0, so we should change all of our numbering to account for that. In order to write down a number, we simply have to create a variable and assign it the value we want. To check the first number, we need to access the array. To ignore a number, we do nothing, so there's no code for that. To change the stored number, we just assign the variable a new value, and this only happens when the value is greater than the old max. To check the second and third and so on and so forth, this instruction can be repeated, but this number right here needs to change. As a result, we can use a variable instead of a number. The variable itself needs to be changed sequentially from 1 to the end of the list, and we can use a for loop to do this for us. And that's it. Once the loop completes, it will have assigned the maximum value to max, and we can use that information however we need to.